All right, when we're finding the domain and range of a continuous function, we need to understand that a continuous function means that the dots are connected. When we dealt with discrete functions had just a bunch of dots on the graph. But when we have a continuous function, the dots are connected. So when I say discrete, that means we have points. And when I say continuous, that means we have lines between the points. Okay. Still, domain are the x's. So we're looking for the farthest x's on either side when we're talking about domain. Instead of just saying, here's all the list of points, when we talk about domain and range of a continuous function, the domain and the range will be inequalities. So first, let's do a domain. When we look at domain, we want to look for the farthest left and right the graph goes. So if we're looking at this graph right here, I can see that on the left-hand side, I'm going to kind of draw a little line here, kind of boxing this in. That's where that stops. That graph stops on the left side there. And if I look at the x-axis, I can tell that the lowest point, the lowest x, is -5. When I look at the right side of this function, the highest or the farthest right is actually at +4. So my domain of this function is going to be between -5 and +4. Let's look at how we write that. From -5 to 4, we want all of the x values between them. So I'm going to put an x between them. And it said in our notes right at the top that we are going to have inequalities. So an inequality means I'm not going to use an equal sign, but a less than or equal to sign. And if we break this down, what we see is we have x is greater than -5, but less than 4. And all of our x's bigger than -5, but less than 4 are on our graph, on our line. Okay. We're also going to put curly braces around it, just like we did when we did discrete. We put curly brackets. And then we want to look at the range. The range is not from left to right. It's not the x's, because remember, the range, we're talking about the y values. So for the range, we're looking for the highest up and down. So we want to go up and down on this one. And I can see that the highest point on the y-axis is at 6. And the lowest point is at -3. So again, I'm going to put it in order with the lowest one first, from -3 to 6. And then we have an inequality, so I'm going to put the y in the middle because we're dealing with range, and do less than or equal to for both of them. And curly braces. The last thing we have to answer here is the relation a function? And we can use the vertical line test to tell us that yes, this is a function, because nowhere on this graph, if I draw vertical lines, do I hit the line more than once. Each time I only have one point. Let's look at a couple examples. So our first example, it looks like we have another function because all the vertical lines pass the vertical line test. So I'm going to say vertical line test. So yes, it's a function. I'm going to erase my vertical line so I don't make too much of a mess. The next thing I'm going to do is I'm going to look for the domain. So I'm going to look on the x-axis. What is the lowest point on the x-axis? And it looks like right here would be my lowest point. There are no x's left of that. And the farthest right is not at 6, it's actually at 5. So between 1 and 5, I have my domain. I'm going to write it in interval notation, so I have a 1 and a 5. We're talking about domain, so we put an X in the middle, and then we put an inequality, and we use curly braces around it. We need to do the range. Now the range is actually going to go above and below. So the lowest point on the y-axis is 0, and the highest point on the y-axis that we have a graph is at 4. Now you say, oh, there's a 6 up there on top of the 4, but there's no points up there. None of the line is up there. So we stop at ever the highest point that the line goes. So we're going to again put it in order from smallest to biggest. So 0 to 4. In the middle we have a y, and then we have an inequality and our curly braces. Let's take a look at the next example, because we're going to see something a little different on this one. So on this one, the question we have to start off with is it a function? Does it pass the vertical line test? And everywhere I go, I only hit the function at most once. So we're going to say, by the vertical line test, yes, it is a function. The next thing we're going to look for is the domain. So I'm going to go the farthest left. So I'm going to kind of box it in, and the farthest right. And it looks like the x's go from -2 to +2. So I'm going to put my curly braces. The range does something a little weird, but we again go from -2, except this time we go up to 3. And we're talking about y for range. Now, I want to draw your attention to the fact that this right there is an open circle. And if you remember from our inequalities, when we're solving inequalities, when we have an open circle, that means it's not equal to. If we have a closed circle, then it's equal to. Which means when we go and look at our graph, when we're talking about the ones that are at the lowest y value is not equal to, it's just less than. And the highest x value is just less than. So I want you to notice whenever we see that open circle, we need to use just less than and not less than or equal to. A couple more examples for you. Is this relation a function? And if you notice, when I do the vertical line test, on several times, I hit the graph more than once. So I'm hitting that circle on the top and the bottom. So is this a vertical? Does this pass the vertical line test? No, it is not a function. Is it a function? No. However, we can still talk about domain and range, because we can say domain, the furthest left and right. And we can talk about range, the highest and the lowest it can be. So it looks like, since this is a circle, it goes from 0 to 6 and 0 to 6. I'm going to go ahead and do that. So my x's are less than or equal to. And my y's are the same. The next one has a kind of topsy-turvy spin to it. So I want to first say, is it a function? I'm going to test it using the vertical line test. Do I ever hit that more than once? And the answer is no. In the middle, it's almost. It's very close to being straight up and down, but I still am only hitting each time. I'm only hitting it once. So it does pass the vertical line test. So is it a function? Yes. The domain, I want to talk about the furthest left and right. I want you to notice that we have an open circle. So on the left side, we don't use less than or equal to, we just use less than. On the right side, we don't have an open circle, so we're going to go ahead and use less than or equal to. And it looks like it's from -5 to +4. I'm going to use the curly braces. For the range, I have to put a line underneath, and it looks like it's -5 to +2. And those don't have open circles, so I'm going to put equal to for both of those. I want to take a look at these last two examples. Is this a function? Is this a function? The one on the left is yes, it's a function. I never hit that line more than once. But the one on the right, nope. It fails the vertical line test. Next, let's talk about domain, the furthest left. Furthest left. And I want you to notice something about the right-hand side of this. These two functions have arrows on the end of them. So what does that tell me? That tells me that these lines don't stop at the end of this graph. They keep going literally forever. So where does this one stop? Where's the furthest right? Does it stop at 7, 8, 9, 10? No, it actually goes from 0 until it gets to infinity. Now, it can never actually be equal to infinity, so we're just going to leave it as less than and never equal to infinity, because it's never actually going to get there. On the right-hand side, we have kind of a similar one, except instead of starting at 0, it starts at -3. But we don't have an open circle, so it goes -3 is less than or equal to x is less than infinity. And then we close our curly braces. For a range of these, the one on the left, we have a minimum at 1, but it goes up forever. So there's actually no maximum. And the one on the right actually goes up forever, and it goes down forever. So the range is from -infinity to +infinity. All right, and that's that.